Space, infinite, ominous, perplexing and, well, spacious. Did you know over the last 67 years, more than 15,946 objects have been launched into space? With that in mind, it's hard to ignore the thought, is there garbage orbiting the Earth? It's a thought that might seem outlandish at first, but when we peel back the layers, we find a reality that's both fascinating and somewhat alarming. Yes, there is indeed what we could call space garbage, or more scientifically, space debris in orbit around our planet. You see, space isn't as clean and empty as we might like to believe. In fact, it's home to a surprising amount of detritus. Picture this. Millions of pieces of space debris are currently whizzing around the Earth at speeds of up to 17,500 miles per hour. That's faster than a bullet, and each piece, no matter how small, has the potential to cause significant damage. This debris is not composed of banana peels or soda cans, as the word garbage might make you imagine. Rather, it's made up of defunct satellites, spent rocket stages, fragments from disintegration, erosion and collisions. Even tiny flecks of paint can be found in this celestial landfill. But how did it all get there? Well, since the dawn of the space age in the mid-20th century, we've been sending objects into space. Some of these objects, like satellites, have a planned lifespan and purpose. But once they've fulfilled their role, they can linger, becoming part of the growing collection of space debris. And it's not just the big, obvious pieces we need to worry about. Even small fragments, perhaps from a satellite that's broken apart, can pose a risk due to their incredibly high speeds. So yes, there is indeed garbage orbiting our planet. When we talk about space garbage, what exactly do we mean? Again, the term space garbage, or more scientifically known as space debris, encompasses a wide variety of objects orbiting our planet that no longer serve a useful purpose. Imagine this, you're at home and you've just finished a hearty meal. Now you're left with a pile of leftovers, packaging and perhaps a broken dish or two. This is very much akin to the situation in space. The leftovers are defunct satellites, retired after years of service, left to aimlessly wander the celestial void. Just like the packaging from your meal, spent rocket stages, once vital for propelling spacecrafts beyond our atmosphere, are now simply discarded, floating around in the vast expanse of space. The broken dishes? They represent fragments from disintegration, erosion, and collisions. When a spacecraft is decommissioned or a satellite malfunctions, parts can break off, becoming individual pieces of debris. Erosion can occur due to harsh space weather conditions, and collisions between pieces of debris can also generate more fragments. And just like that pile of leftovers at home, the amount of space debris is growing. Every space mission, every satellite launch, and every space collision potentially adds more debris to the mix. But it's not just big pieces we're talking about. There are millions of smaller particles too. From flecks of paint that have chipped off spacecrafts to tiny fragments from collisions, these particles may be small, but at high speeds they can cause significant damage. And let's not forget about the odd bits and bobs. Astronauts have lost tools during spacewalks, and these too have become part of the orbiting junk. There's even an astronaut's glove and a camera floating around out there. So, much like the Earth, space has its own pollution problem. It's not just old satellites. The variety of space garbage is quite astonishing. We've essentially created an outer ring of rubbish orbiting our planet. And if we don't start addressing this issue, it's only going to get worse. Now, the space debris we see orbiting our planet is primarily the byproduct of human activity in space. That's right, it's our own mess. When we launch satellites, conduct space missions and carry out experiments in space, we inadvertently leave behind a trail of trash. Think of it this way. Every time a satellite is launched, it doesn't just go up there alone. It's accompanied by a rocket, which often breaks off into pieces once its job is done. These pieces, some as small as a fleck of paint and others as large as spent rocket stages, then remain in orbit around the Earth at high speeds. Space missions too contribute to the problem. Astronauts on spacewalks might lose a tool or two, or a small piece of equipment might accidentally float away. Even though these incidents seem minor, they add up over time. Then there are the experiments conducted in space. often designed to study the effects of the harsh space environment on various materials and technologies. While these experiments provide valuable data, they also contribute to the growing collection of debris circling our planet. And let's not forget about the defunct satellites and space probes. Once their operational life is over, they don't just disappear. Instead, they become yet another piece of junk in the vast space landfill. In some cases, the debris is the result of space collisions or explosions. When two pieces of space junk collide at high speeds, they don't just bounce off each other, they shatter into hundreds of smaller pieces, each capable of causing further collisions and creating even more debris. So, to sum it all up, every bit of space debris has a story. It's a story of human ambition, exploration, and unfortunately, the unintended consequences of our actions. It's a story that underlines the fact that even in the vastness of space, our footprint is visible. In short, we humans are the source of the garbage floating around in space. You might be wondering, why should we care about this garbage? Well, the answer is a twofold one. Firstly, space debris poses a significant risk to both manned and unmanned space missions. Secondly, the accumulation of this debris could lead to a phenomenon known as the Kessler syndrome. Let's delve into these risks a bit further. Space missions, be they manned or unmanned, are an intricate ballet of precision and timing. Even the smallest piece of debris, traveling at speeds of up to 17,500 miles per hour, can cause catastrophic damage upon collision. Imagine a tiny screw or a fleck of paint causing a tear in a spacecraft or damaging essential equipment. It's not a matter of if these accidents will happen, it's a matter of when. Now, onto the Kessler syndrome. This theory, proposed by NASA scientist Donald J. Kessler in 1978, suggests that the density of space debris in low Earth orbit has reached a critical point. Collisions between debris could create a cascade effect, where each collision generates more debris, leading to more collisions. This could potentially render space exploration and the use of satellites unfeasible for many generations. What's more, the abundance of space junk could also impact astronomical observations. The debris can reflect sunlight, causing false signals or noise in observations. This light pollution from space debris can interfere with our ability to study celestial bodies, hampering our understanding of the universe. The bottom line is this: the garbage in space isn't just an eyesore or a nuisance, it's a serious threat to our ongoing exploration and use of space. We rely on satellites for everything from weather forecasting to GPS navigation. If we want to continue reaping the benefits of space exploration and satellite technology, we need to take the issue of space debris seriously. The garbage in space is not only a nuisance, but a serious threat to our ongoing exploration and use of space. Is anyone doing anything about this problem, you might ask? Indeed, the situation seems dire, but there's cause for optimism. Around the globe, efforts are underway to mitigate the space debris problem. Let's dive into some of these initiatives. First, let's discuss international regulations. Space is a global commons, which means that all nations have a part to play in keeping it clean. International bodies like the United Nations Office for Outer Space Affairs are working tirelessly to create and enforce regulations that reduce the creation of new debris. These regulations include measures such as the passivation of satellites, which involves depleting all the energy of a satellite after its mission ends to prevent accidental explosions that could create more debris. In addition to regulation, tracking debris is a critical step in managing the problem. Organizations like the United States Space Surveillance Network and private companies are keeping a close eye on the sky, cataloging and tracking tens of thousands of pieces of space junk. This information is invaluable in avoiding collisions and planning future space missions. But what about the debris that's already there? Enter the concept of active debris removal, or ADR. This is still largely in the realm of research and development, but several promising projects are on the horizon. For instance, the European Space Agency's ED orbit mission aims to capture derelict satellites with a robotic arm and safely guide them into Earth's atmosphere for destruction. Japan's Astroscale is another organization making strides in this field. They're developing spacecraft designed to dock with defunct satellites and guide them to a safe re-entry path. This is no easy task, but the potential benefits are enormous. And let's not forget the role of innovation. From laser brooms that sweep debris out of orbit to space tethers that slow down and deorbit satellites, creative solutions are being explored every day. Despite the daunting nature of the problem, efforts are underway to clean up our cosmic backyard. From international cooperation and regulation to advanced tracking and innovative debris removal projects, we're taking steps to ensure that space remains a safe and sustainable frontier for generations to come. So, to quickly recap our journey into space garbage, yes, there is indeed garbage orbiting the Earth. This isn't just your everyday trash, but a variety of discarded objects from defunct satellites to fragments of spent rockets. The origins of this space debris are largely human-made, stemming from our numerous explorations and activities in space. The impact of this space garbage is far from negligible, posing significant threats to both manned and unmanned space missions. It's a challenge that underscores the importance of responsible space exploration and utilization. But all is not lost. There are ongoing efforts to tackle this issue, from devising methods for garbage collection in space to implementing stricter regulations on space missions to minimize the creation of new debris. While there is garbage orbiting the Earth, we're not just standing by and watching. The cosmos is our frontier, and it's up to us to keep it clean. Did you learn something? If you did, like this video, subscribe to our channel for more content.